morning all. So in the previous class, we have started the concept of inheritance. Okay. So what is inheritance? What are different forms of inheritance you have seen, right? So basically, inheritance is one of the basic concept of object-oriented programming. So as you are aware, okay. So and it is the backbone of the object-oriented programming. Okay. So basically, what is inheritance? So inheritance is a mechanism basically. So in which a class can acquire the properties and the methods of another class. Okay. So as we discussed the previous class, for example, A is the existing one and the B is the new one. Now using the concept of inheritance, so now the class B acquires the properties of class A. Okay. Class B acquires the properties of the class A. So this is nothing but inheritance. Okay. So now using inheritance, what we will do is, so some already tested and debugged programs or classes are available. Okay. So these tested and debugged classes can be reused for some other purpose or some other applications. Okay. So this is called the definition. This is one of the key concept of object-oriented programming. Okay. So what are different types of inheritance seen? So now in the concept of inheritance, so there are two classes exist basically. Okay. So for example, this is class A is the existing one. So whose name will be so parent class or sometimes you refer super class. Okay. So parent class or super class. This is also known as the base class. So different names are there here. So the now the new class is the child one, child class, or another name is the subclass or derived class. Okay, or derived class. So these are the two classes available in the concept of inheritance. That is the super class. So now this class is the existing class. Okay. So from which another class or the subclass is derived. So that is the super one or the existing class. So what is the subclass? Subclass is the new class, this one. So a class that is derived from another super class. This is called subclass. Okay. So a class that is derived from another or existing class is known as subclass. Okay. So subclass can have only one superclass here in this context. Okay. So a subclass refer only one superclass. So because there is no concept of multiple inheritance here. Okay. So that's why only a subclass refer only one superclass. Contains only one superclass. Okay. So this is the concept of inheritance we have seen in the previous class. So class A, this is one class A is there and class B is there and this is class C. Now B extends A and C extends B. So now this is called the hierarchy of the classes. This is known as the hierarchy of classes. Now class A is the superclass of B and here class C is the subclass of B and class B is subclass of A. Okay. A is the superclass and B is the subclass of A. And if another class is there, C is the subclass of B. So like that, you can create multiple classes in the class hierarchy. So what are the benefits of this inheritance? One of the inheritance allows the reusability of already developed and debugged class. Reusability of the already developed and debugged class programs. So without any modifications. So one of the key concept is the reusability. And second one is inheritance allows number of subclasses to fulfill the needs of several subgroups. So if you want to provide additional functionality or extra functionality, we can add it. So another advantage is the large programs are divided into suitable number of classes and the subclasses, and that may be developed by separate teams. Okay. Now each individual team prepares a separate module. This is one module as one subclass. This is another module as another subclass. Okay. So later on, all the subprograms share some data. So using the concept of this inheritance. Okay. So this is one of the key concept, key advantage or the benefit of the inheritance. So these are the general forms of inheritance you have seen. So one is the single inheritance. Second one is the multiple inheritance. Third one is the hierarchical inheritance. And last one is the multiple inheritance using the concept of interfaces. So Java does not support multiple inheritance directly using class concept, so that we can use the concept of interfaces. Okay. So these are different forms of inheritance earlier in the previous class we have covered. So coming to this first one, single inheritance. So now it is the simplest form of the inheritance. So now in this case, a class extends from one existing class. So let us say class A and class B. Now class B extends A. Now B is called the, in this case, B is called the subclass and A is called the superclass. A is the superclass and B is the subclass. Okay. So now how to apply this inheritance using the concept of using the keyword extends, as we seen in the previous class. How to implement inheritance using extends keyword. So for example, if you want to implement this single inheritance, so let us take this. Suppose let us take on class A. So here we can write one method void show system dot out dot println, and write one print statement here. So this is class A. So what is this class A? Class A is the base class here. So from this, write another class. Suppose class B now extends A. So now this is let it be 1, it will be 2. So this is a class B. Now when you write these extends, so whatever the members are there in class A automatically inherited into class B. Okay. So for example, let us take this. So this is one class A and this is another class B. So now this is class A. Now this is class B. Now B extends A. B extends A means now B acquires the properties of class A. So what are the properties of class A? Now it has one method show one. Now B has its one member, that is show 2. Now when you apply inheritance, now class B acquires the member of class A. That means we can access the member of class A, that is show one, from the context of class B using the object of class B. So we can refer both methods, that is show one from class A. This is automatically inherited into class B. The show one as well as show two. Okay. So, but A cannot access the members of this. In the reverse direction, it is not possible. It cannot refer. Okay. So, of course, it is there using uh, dynamic method dispatch, that is different. So this is the thing happened when you write like this. Okay. So now, if you want to access the members of both A and B, now class B object is enough. So using class B object, so we can access show one and show two, both the methods. So here we need to write one main method. So this is public, and then static void main. So it takes an array of strings. Okay. So this is using object of class B, you can access the members of both A and B. We want to run this, suppose Java C single inheritance dot Java. Java single inheritance. So this is class A and this is class B. Now both the methods of class A and B are invoked using object of class B. Okay. So this is called single inheritance. Next, coming to the next one, multi-level inheritance. Second type of inheritance is the multi-level inheritance. Now, in this type, what you have to do is you can derive a new class from the parent class and again derive another class from the derived class. That is deriving a class from another derived class. Suppose this is class B. So B is derived from class A, and again derive another class C. C is derived from class B, which is already derived from class A. Okay, deriving a class from another derived class. So that is comes under this multi-level inheritance. Now in this type, a derived class inherits parent or superclass, and again the derived class also acts as the parent of the another class. Okay, that is if C is there. Now for C, B acts as a parent class. Okay, for B, A is the parent class. Okay, in the reverse direction, B is the subclass of A and C is the subclass of B. Okay, so that is called this multiple inheritance. Suppose if you want to show this, so let us take this is class A and this is class B and this is class C, suppose. So let us take this is a class, the first class is there, animal class is there, and the next let us take one dog class is there. So another class, puppy class is there. So there are three classes are there. Now the dog class is derived from animal, and this puppy class is derived from dog. So suppose here one method is there here. This is show one method, and this is another method, show two, and this is another method, show three. Now when you apply the concept of inheritance, now when dog class extends animal, now it includes the member of animal class. And when you apply again inheritance, that is the puppy class extends dog, now this includes the members of this dog class, that is show two and as well as this is show one. Now the puppy class includes the members of this animal class as well as this dog class. Now both the members are available in the puppy class. So this is called the multi-level inheritance. This is known as the multi-level inheritance. That is deriving a class from another derived class. So is known as multi-level inheritance. So for example, if you want to simulate this, so let us take this is class, suppose animal class. Let us write this is animal. So here you can write this is a class animal class. And next this is the dog class. Now dog extends animal. Dog extends animal. Now this is the class dog. This is the dog class. And let us write another class for C for B. Now this puppy class extends dog class. Three words. Puppy class extends dog class. This one. So this is another method, right? Another method here that is shown three suppose. So this is the class puppy. This is my puppy class. Now in order to invoke all the methods, now let us create one object for this puppy class. Puppy p is equal to new puppy. Now p dot the first method that is show one, and then p dot show two, and then p dot show three. Okay. Now using the object of this puppy class, we can invoke the members of both the dog class and animal class. That is animal, that is dog extends animal, and puppy extends dog. Now both the members of that is dog and animal are inherited into puppy class. Okay. So this is the multi-level inheritance. Multi-level inheritance. Now let us compile this program. So Java C single inheritance Java. Now this is the class animal, this is the class dog, this is the class puppy. So now all the three methods were invoked from the object of this puppy class. So this is known as the multi-level inheritance concept. Okay. So next coming to the another form of inheritance. So hierarchical inheritance. Let us take the next one is the hierarchical inheritance. Now in this case what happened is, so a class is generally inherited from one basic class. That is, there are several subclasses are there. This is the class B is one subclass, and class C is another subclass. Suppose class D is another subclass. Now all three subclasses are extended by this from the class A, where A is the superclass. If A is the superclass, then class B acquires the properties of A, and C acquires properties of A, and D acquires the properties of A. That is, B extends A, and C extends A, and D extends A. That is, a superclass have multiple subclasses. So now this is known as the hierarchical inheritance. Okay, that is this type. What happened is, so one class is inherited by many subclasses. Okay, class A, class B, class C. So what happened is, now B acquires the properties of this A. Now it does not acquire any properties from class C and class B. And similarly C. Now C contains only members of A. Now it does not include the members of either B or D. Similarly D acquires the members of A only. So now it does not include any members of class B and class C. So this type of inheritance is known as the hierarchical uh, inheritance. Okay, hierarchical inheritance. So now let us see an example. So for example, let us take multiple classes. So this is one class. This is another class, and this is another class, and this is another class. Suppose. So let us take this is class A. This is class B. This is class C. And let us take this is class B. Now when you apply inheritance, what happened is B extends A and C extends A and D extends A. Suppose if you have one method of this, here you have one method add in class A and subtract in class B and division class C and multiplication in class D. So we have four different methods in all four classes. Now when you extend this class B to A, now class B includes the members of A and B only. And similarly, when you apply class C extends A, it includes the members of A and C only. Now using class D, we can access numbers of A and D only. That is, it includes here add and subtract. B includes add and subtract, and C includes add and division, and D includes add and multiply only. That is, object B refers these two methods, object C refers these two methods, and object D refers these two methods. So this is known as the hierarchical inheritance. So this is called hierarchical inheritance mechanism. So now let us see an example program how to implement this, how to simulate this. So let us take this is class A. Now class A includes one method, suppose add. Let us take the two methods int A comma B, and then this is the addition is. So here you can write A plus B. This is the add. Next, let us take class B extends A. Then here include one method subtract SUB. Here you can write subtraction A minus B. And write another class C again extends A. And then write one method, suppose multiplication. So multiplication is here A star B. And write another method, suppose class D. Now D also extends A. This is the division. Let's take double A, double B, and write a division is A by B. So this is the hierarchical structure of the classes. So this is class A, and then class B extends A. Now C extends A and D extends A. Okay. So now, in order to access, invoke the members of all the classes. Let us take A. A is not required using object of class B, B, and object of class C, and object of class D. So there are three different objects of area, class B, C, D. Now using B, what you can do is you can invoke B dot add as well as its own member, that is subtract. And similarly, using object C, you can invoke member of A, that is add, as well as its own member, that is multiplication. And similarly, object D, you can invoke add method of class A and its own method, that is division. Okay. So this is the implementation of the hierarchical inheritance. So there are four classes are there here. Class A, this is the base class, and class B extends A, one derived class of A, and second derived class of A is C, and third derived class of A is D. Now each class has its own method. Okay. So then finally create object for this class B, and then class C, and then class D. Okay. So using object of either B, C, D, so you can access the member of class A. So as illustrated in this figure, that is add is accessible from B and C and D. Okay. So that we can create object of BCD and invoke B dot add, C dot add, and D dot add with the different parameters. Here the parameters are different here. Okay. So now B dot sub its own method. This is sub is its own method, and mul is its own method, and division is its own method. Okay. So this is the implementation of the hierarchical inheritance. So now you want to see the results. So compile this code and run. Now addition, that is in class B, addition is 46 here, that is 12 and 34. And whose subtraction, its one method is the subtraction method. Next again invoke addition using class C, that is 23 and 12 is 35. So and its multiplication 23 star 3 is, that is 69. And again invoke addition method using object of D, that is 34 and 56. This is 90. And its own method is division 34 by 6, that is 5.6667. So this is the result of this hierarchical inheritance program. So this is about the third form of inheritance, that is hierarchical inheritance. Okay. So next, this is the illustrations. So this is the general form what we have seen. So this is the implementation of single inheritance, that is class A, and then class B extends A. So this is the single inheritance. Next, this is the multi-level inheritance, that is class A, and B extends A, and C extends B. Okay. Next, this is the hierarchical one, hierarchical inheritance. So public class A, and then B extends A, and C extends A. So this is what we have seen just now. Okay. So next, this is multiple inheritance is there. This is, we will come back soon. So we need to discuss about the concept of interfaces here. Okay. This is the example for single inheritance program. Another example. So here we have one display method, that is in demo class. So display A and display B. So now both the methods are invoked using object of B. So next one is let us see the use of this super keyword. So use of the super keyword. So now there is a keyword called super, right? So now its general purpose is its name itself tells us super. Super means it is always refers super class. Okay. So it always refers super class. That is, if you see the class here, class A is called the super class in this context. So class A is the super class here. Okay. So now super class consists of some variables and some methods are there. So variables, super class, that means a class means in general it consists of. So one is the variable. It has the variables. And the second one is the methods. It has some methods. And third one is it has constructors. It has constructors. So now if you want to refer the superclass variables and superclass methods and superclass constructors from the derived class. Here there are three classes, class C, B, C, D are the derived classes here. The B, C, D are called the derived classes. Now class A is the super class A. Okay. Now if you want to refer the members of super class from derived class, if you want to refer the members of the super class from the context of derived class, that is, what are members of super class? Variables are there and methods are there and constructors are there. Okay. Now, if you want to refer the superclass variables and superclass methods and superclass constructors, okay, then use the keyword super. The keyword super is used to refer superclass variable. Is used to refer superclass variable and superclass method and superclass constructors. Then use the keyword super. So that is, there are three uses of the super keyword. There are three uses of super keyword basically. So now let us see. So one is called, what is the first use of the super keyword is to distinguish between the having the same naming superclass as well as the subclass. This is the first advantage of this super keyword. Okay. That is, for example, let us take, this is one class and this is another class. Let us take the concept of single inheritance. Okay. So now here the variable int x, y are there. And again, here also int x, y are there. Okay. Now when you apply the inheritance, okay, when you apply the inheritance, this is class A and this is a class B, suppose. Now when B extends A, when B extends A, the members of class A, X and Y, and the same variable is also there in class B. Okay. Now here this X and Y represents, this X and Y represents actually from the programmer's perspective, this represents class B members. So this XY represents class A members. Okay. Now when you apply inheritance, now if same variable is there in both base class and derived class. Okay, the same variable is there in both base class and derived class, and it is referred from base class object, then from the referred from the not base class, derived class object, then the base class variable is hidden. Okay. So that is, we will get derived class version. Okay. So we'll get only the derived class version of the variable. So what about this base class? So base class version of the variable, or the value of this base class variable will be hidden. So by default, this derived class variable hides the base class value. Okay. Now, in order to avoid this problem, now what is the solution? The solution is use of super keyword. Use of super keyword. Okay. Use of super keyword. So using the keyword super, so then what you can do is you can refer the super class variable from the derived class. For example, here x and y are there. Now what you have to do is use super dot x. Now the super dot x represents super class variable x, and similarly super dot y. Now the super dot y represents super class version of the y. Okay. Now this is the advantage, one of the advantage of the super keyword. Okay, that is referring super class variable from the derived class using super keyword. Now let us simulate this as a program. Now let us take class A, suppose. Now in class A, there is a variable x comma y. There is a variable x, suppose. Okay, there is a variable x. And here we have one constructor A. Now in this constructor, I am initializing x equal to 100. And B extends A. So let us take x comma y. And here we have one constructor x. Here I am writing x equal to 200. And then y is equal to 300. Y is equal to 300. Okay. Y is equal to 300, suppose. So now I want to access, suppose I am creating object for class B, B equal to new B, then system dot out dot println. Here I am writing x equal to x. Okay. So now here x equal to 100 and here x equal to 200, suppose. Now just I wanted to print the value of x using derived class object. Now let us check what happened. This is Java C. So let us take synchronous. So this is uppercase class Now let us compile the code. Ramesh. Okay. So this is p dot x, Java C, and then Java compile this code. Now x equal to 200. Now we got the value of x equal to 200. So from where we got this? This is the derived class version of the variable x. Okay, derived class version of the variable x. What about this base class version? This will be hidden. Okay. Now instead of getting this x equal to 100, this is we got x equal to 200 because the variable x in derived class overrides variable x in superclass when you apply the inheritance. Okay. Now to avoid this problem, what we have to do is, so for example, write one method while. So here I am writing one method while show method. So inside this, what you have to do is print the variable x. This is the superclass variable. I want to display super x equal to. Here you can write super dot x. And if you want to print the value of its own member, that is, this is the subclass x equal to directly write x. And similarly, print its y value. Now the subclass y is equal to y. So close this for that. So now using object of class B, then invoke the method p dot show. P dot show method. Okay. So now again let us compile the code Java C and run. Now super dot x equal to 100 we got. So in the super class, what is the x value? The value of x is equal to 100. Okay, this one. And the value of y x in subclass is this is 200, and value of y is 300. Okay. So this is the one of the advantage of the super pivot, that is to access the super class variable. To access the super class variable. And now let us see another use of this super keyword is, second advantage of this one is to access super class method. To access the super class method. This is the second advantage of this super class. So now why this is required? So why this is required is, suppose let us take this statistics. Okay. So now if same method with the same name and the signature with different implementation. Is there in both superclass and subclass. Okay. So now this is the second case where we have a method. So if the method is having the same name and the same signature, so same signature means that is same number, same return type, same number of parameters, so same type of parameters. But the implementation is different. Okay, implementation is different, suppose. Okay, so that is called the same method with the same name and the signature with a different implementation. So it is there in both the superclass and the subclass. So and it is invoked with subclass object. So now in this case, what happened? Then superclass version is hidden. Okay. The superclass version will be hidden. So, and we get only subclass version. Okay. So this concept is known as method overriding. This method is known as method overriding. There is a concept called method overriding. Okay. So that is the same method is there in both base class as well as derived class with same signature, but with a different implementation. So, and if you are trying to access the method with the derived class object, then it automatically hides the base class version of the method, and it will give you only the derived class version. Okay. So, for example, let us take classes here again. So, this is class A and this is class B. Okay. So, and apply the concept of inheritance. Now, B extends A. B extends A. So, and moreover, this consists of one method called show, and again, this method is also having the same method display, that is show method. Now, when you apply the inheritance, what happened? B extends A. Now, the show version of this class A is also available here. Now, this show represents this one, and this is the its own member. This show is the its own member. When you are trying to invoke with object B, suppose B equal to new B. So then B dot show. Now this refers to this method only. Okay. So the version of this base class or the superclass will be hidden. Okay. So this is the problem. Now in order to avoid this problem, what you have to do is use the keyword this super keyboard. Okay. Now here what you have to do is, while inside this show method, use super dot show, that is use super dot show. Now the super dot show always a reference, always refers to this super keyword, that is the version of A will be invoked when you use this keyword super. Okay. So this is the use of the super keyword. Okay. So now let us write on example program. So here we have one class A and one method known as show method, and it is used to display the value of this, display the value of the instance variable, that is x. Okay. Instance variable x, that is system.out.println super x is equal to x, this one, and the same variable is there here, the same method is there in y, and on constructor y is equal to 300. Now the method name is same here, so void show, its return type is same and the method name is same, but the implementation is different. Okay. So now I am trying to invoke the method using derived class object, that is B. Okay. So see what happened. I compile this and run. Now you will get only the derived class version, that is sub y is equal to 300. Sub y is equal to 300. Okay. So what about this base class version of the show method? That will be hidden. Okay. So when you call this method, overridden method, using the derived class object, it automatically hides the base version, that is base class version of the show method, that is system.out.println. So for x equal to x. Okay. Now in order to invoke this superclass version also, then what you have to do is inside this method write super dot show. So either you can include this statement in the beginning or and in the method, there is no problem. Okay. So now when you compile this Java C, then Java, let's say. Now the sub y is equal to 300. So for y is equal to 100. Okay. So now this superclass version of this method will be invoked from the derived class. So this is a second use of the super keyword. Okay. Second use of the super keyword. Now the third use of the super keyword. Coming back to this. This is the second usage. Now it is used. Okay, when a member is called now within the, from the subclass object, what happened? The subclass value will be presented and the superclass value get hidden. Okay, so for getting the superclass value or for calling the superclass method, what you can do is use the keyword super. Okay, now the last use of the super keyword is that is if you want to define a subclass constructor. If you want to define the subclass constructor, that is, if you want to initialize the superclass constructor from the derived class instance, so that is instead of repeating the assignment of variables of superclass, then what you have to do is use this super keyword from the derived class constructor. Okay. So let us come back to this here. Let us take one class. So here I have two classes. So this is one class A. This is another class B. Now class A has its own constructor here. Class A has one constructor. Okay. Now this constructor takes one variable x. Okay. It takes one variable x. And here I am writing this dot x equal to x. That is, I want to initialize the variable that is x. For example, it has one instance variable x. I want to initialize this. And similarly, here I want to initialize the variable y here. Now here class B has its constructor. So int A and int B is taken two parameters, suppose. Okay. Now from this class B, I want to initialize x. Then what you have to do is use the keyword so far. Use the keyword so far as the first statement here. Then you can initialize this variable y as usual. Okay. So when you apply the inheritance concept like this, okay, then I want to initialize this. That is the instance variable x in the parent class from the derived class constructor. When you use the keyword, so far as the first statement in the constructor. Okay. So because in general, when you call the constructors, when you create an object for the derived class, okay, so first it is going to invoke the constructor of its base class. Constructor of its base class. For example, if you want to create object for B, now it immediately invokes the constructor of its base class. What is its base class? That is A. Okay. So, for example, if you want to see this, let us take this example. So, I am writing only one constructor here, nothing is there. So, inside this constructor, I want to write this statement. There is no method here. So, this is here write one statement. So, this is class A, suppose. This is class A. Yes. So, like this, what you can do is write on class B. Suppose class B extends A. This is the constructor of class B. So this is obviously this is class B. Okay. So next, let us take another class C. Now class C extends class B. Now this is the constructor of class C. This is the constructor of class C. Now suppose I am creating C object C. This is class C. Okay. So now when you compile this Java C, so this is outside this. This is class A. This is class B. Class C. Now compile this code and run Java. Now when we are creating object for class C actually, now first it is going to invoke, this is class A, that is the base class of this entire class hierarchy. Okay. Now that is when you invoke this, when you create object for class C, it is obviously going to invoke constructor of B. Now when we call the constructor of B, it in turn invokes the constructor of its base class, that is A. So that's why class A and class B and then class C. Okay. So because of this reason, what you have to do is you need to go, write this super statement as the first statement in the derived class constructor. Okay. So in the next class, we will see the implementation of this particular application of the super keyword to initialize the instance variables of the super class. That is super class, invoking super class constructor from the derived class. Okay. Thank you.